Okie dokie. Thanks, Ketan. Let me share my screen first. Make sure I have the right thing. Well, can everyone see this tapestry up top here? Awesome. Okay. Cool. Yeah. So, hi everyone. My name is Niels Bantilan. I'm an ML engineer in the Union AI team, and today I'll just quickly demo this functionality that we sort of unearthed chatting with the applied AI folks about using decorators to customize tasks and workflows. Kind of the subtitle of this is kind of a functional-ish API for extending or modifying the behavior of tasks and workflows. And I'll show you why it's ish and not exactly pure functional. So just to give you some context on what the current state is of customizing Flyte, there are basically kind of three ways of extending it. So there's Flyte kit, either Python or Java. I'm not sure what the exact state of extension is in the Java Scala SDK, but for now I'll just stay within Python land. So one of the ways to do this is defining custom types by the type engine and type transformer API. So an example of this would be Pandera. I might jump into these examples, but just for the sake of time, I'll just move on. The second type of extension is via custom tasks with the task plugin API. So an example of this would be the SQL Alchemy plugin. And then finally, backend plugins, for example, Kubeflow, AWS SageMaker, things like that. And in the documentation, I've pulled this image out of like this decision tree of when to deploy what type of approach. So for example, if you want to use some kind of remote service and you're familiar with Go, then writing a Flyte backend plugin makes sense. But if you're in Python and you just want a quick, if you're experimenting or if you're not using a remote service, then creating a custom type or a custom task type would make sense. We have demos of this, like presentations in previous OSS sync-ups. So I'll link this to you after this if you're interested in checking those out. That said, there is a fourth way. And this, I think, was like almost already being supported, but we had to do just like a minor tweak of FlyteKit Python to get this off the ground. But this is kind of a preview, and it will require FlyteKit 0.24 or greater. And basically, this is a locally built Flyte stacks. I'll be pushing this up later today / this week. And so really the use case for decorating tasks and workflows is I'm like quickly experimenting or prototyping, or even I just want to use decorators, like this pattern that's quite useful in Python. You're familiar with it. But I can use decorators to then modify the behavior of tasks in the same way that I would decorate any old Python function to modify its behavior. So if we just take a peek at this single decorator example, I'm defining this log.io function, which is a decorator. And I'm defining within it a wrapper function that will wrap this input function here and the log.io function here. But I'm going to modify what happens before and after calling this function. So in this case, I'm just going to log the inputs and outputs of whatever function I've passed into log.io. And then also I'm going to log the output of whatever is output by function. Great. So this is like regular Python code. This should work, in Python. But it also works in Flyte now. And here, the invocation of the decorators matters. So the at task decorator that we're all familiar with in Flyte should be the outermost decorator. And here I'm just decorating T1 with log.io. And I'll show you later in a sandbox environment, this actually works. I can also stack multiple decorators. So here I'm defining a validate output decorator. Same pattern. Oh, sorry, by the way, stepping back a little bit, this at wraps func tools kind of utility function makes sure that this wrapper thing that's being returned as part of the output of this decorator, this makes sure that the function signature, the doc string, and all of that stuff is bubbled up to the top level wrapper. So Flyte can analyze this wrapper function and see, oh, okay, it's exactly the same function signature as the decorated function. Okay. So really, this validate output decorator is pretty simple. It just looks at the output and checks whether it's a positive number. So if it's less than or greater than, or if it's less than or equal to 0, it's going to error out. So now that we have these two decorators, I'm going to first validate the output of T2, which is this new task I'm defining here, and then logging the inputs and outputs of it. And we can, string this together in a workflow, and I'll show you a little bit later. This should work. Actually, I'll show you now. So here's the sandbox environment. I won't execute this thing, but just to show you the logs of it. Yeah, decorating tasks. So our decorator logger actually logs the inputs and then the outputs of this thing. So this was, our decorator at work. So that's great. I guess one caveat here is that manipulating the function signature of the inner function is not fully tested. I haven't quite thought through the consequences of this, but really, yeah, any pattern that relies on this at wraps decorator pattern will work in Flyte. Next, I'll show you decorating workflows. This requires a little bit more work, but if you want to do something like establish a setup teardown pattern that relies on an external service, you can inject tasks into a workflow function body using decorators, which is pretty neat. So in this example, I'm just going to mock out an external service. So this external service has some initialize and some complete method. For people who are familiar with weights and biases or ClearML or similar types of packages, you can see like weights and biases have, and both of these libraries have this kind of API where you initialize something with some ID and some other metadata, and then you can complete it, mark it as failed or complete at some point during execution. But in this case, I'm defining two tasks, setup and teardown, and this doesn't rely on any state or any inputs and outputs from my main function body, like the workflow body, which is where this works very well. And then I define a workflow decorator. And this is kind of similar to the decorator I defined for tasks, but here I'm doing a little extra work. We might refine this example to make it seem a little less like we're kind of dissecting and doing all sorts of operations inside of a workflow. But basically what's happening is I'm getting the current context of the current Flyte context. I'm creating a node, and this before argument is a task. This is a Flyte task, so I'm creating a node here to produce a before node. I'm executing the workflow function body, so this then makes the compilation state consist of the before node and then the bunch of nodes that this function produces. and then the after node, which is the same thing. And basically the compilation state of the workflow looks kind of like this, simplified version. And then this conditional just checks, whether there is a compilation state when this wrapper is being executed, and then makes sure that the before node executes before the first workflow node, and then the after node executes after the last workflow node. I'm doing a few more tricks here, like this partial thing, in order to make setup and teardown a parameterizable decorator. So I'll show you what that looks like. I define two, very simple tasks just to show, to illustrate the point. And here I decorate this workflow. Again, the invocation matters, so workflow needs to be at the outermost decorator. And the setup teardown decorator takes in the setup task and the teardown task, and does some magic. So I'll show you. This is the sandbox environment. This is a succeeded thing. We can see that setup executes here, our T1 and T2 executes, and then there's the teardown. So our graph looks like this now. So this is pretty neat. I know that we have a few things like exceptions and error handling in workflows, but those things aren't, still working on those. And so this is a really neat way of at least writing the setup teardown pattern in workflows. A caveat is if any of these error out, this teardown I don't think will execute. But I guess there will be ways of doing that in the future. And that is it for the demo. Again, this will be released as part of the 0.24 release. And yeah, I'm excited to see what kinds of interesting things come out of exposing this new feature.
That's awesome. See some new folks. Any questions from anybody? You can just do a general questions, or anybody wants to share anything.
I have a question about what we just saw. The logging example for the task decorator got me thinking, because we currently try to integrate tasks with MLflow logging, and for that you need to set a single environment variable that tells MLflow where the tracking server is running in the cluster. And that could be a neat way to do that, right? Because not every task needs that, but you could just decorate it with MLflow task, and then we typically we set this environment variable, but we could also then just log the arguments that were passed to the task in MLflow, right? So that could be automated in a very clean way.
Yep.
Is that the mechanism that you would recommend, or is there another mechanism that I should be aware of?
I would recommend this actually. I think, Niels, what do you think?
Yeah, I would definitely recommend it.
So there are two ways of doing it, Fabio. So there's the functional way, which is what Niels showed, which is much simpler and cleaner. The other way is to actually write a meta task. And the example over here is Papermill for notebook tasks. What they allow you to do is they kind of hijack the function call, do whatever they want with that function call before proceeding to actually call the underlying function. And the way it is done is that you compose tasks of each other. So that means you don't lose the distributed PyTorch and distributed Spark and all of that. They continue to run, but you still hijack that body just before the invocation. But if you're just doing that, this is much simpler actually. We should look at if notebook tasks can be just rewritten using this and made it like 100 times simpler. So
will distributed tasks using the Kubeflow pipeline, sorry, the Kubeflow operators will work if we put the decorator after the task decorator that uses the PyTorch job? That will work?
It will work. The only thing is, so in a distributed training environment, what happens is Flyte really doesn't know that it's distributed, right? So I mean, the engine doesn't know. So what it's doing is like launching and it's waiting for a signal. And so only one of them can return. If all of them return, that's like a weird scenario, right? Because like, let's say you're training, it's only one model wins, it's not all models. So there is a case in which you raise an error called ignore outputs. It's a meta error. That error just causes like silent ignoring of the outputs so out of your rank 0 to n, if everybody else can return the ignore output except for rank 0. And so the decorator should work because the after part will just get an exception and it should just bubble up that exception. And as long as it bubbles up the exception, it should just continue on.
Okay.
Yeah, you get that, right? Like so, but the inputs will be invoked on every single one of them.
Yes.
But that's by design, right?
I mean, what we could do, we can check for rank environment variable and then only do some stuff. Okay, that makes sense. I got that.
Yeah, but the rank environment variable is set by the outer task decorator. So you should get that. Yep.
Yes.
You'll have to look into the context and say like, oh, this is rank 0. All right.
Cool. Good. Thanks.
Awesome. All right. Anybody else?
So any questions about the release process? Any questions about what's going into 18, the versioning plan to switch to a major version up, of 1.0 in March of next year? If that's confusing anybody, please reach out to Keithan or me. If anybody wants to present at this meeting and show your work, reach out to Samitha, Sandra, me, Keithan. We're all on Slack. Any of us can get your stuff in. We'd love to see contributions from the community, and we can. It's every 2 weeks. So obviously somewhat informal. So
yeah. So this week, what we are trying to do is that every Tuesday we do this meeting, and then the following 2 weeks later, the Tuesday, we do a workshop. And we've been doing that for the last few months, where the workshop actually dives into some aspect of Flyte, and it's just like, like maybe the back end or some various things. And we've been doing that for the last few months. Please let us know if that is a good format, or do you prefer just doing a community sync every 2 weeks? Q&A is done every 2 weeks. Like Q&A should be done every 2 weeks. And this is the time for the community. We would love to know what is better. How can we better utilize it? Please let us know. All ears for all of that. And I encourage everybody to use Niels' fantastic method of doing lightning talks. Please do lightning talks. Don't, this is how we will know what you guys are working on. And some of you guys are doing fantastic stuff. We would love to know that. And your use cases. Please talk about your use cases. That's even better. And probably I'll have to reach out to folks, but I would prefer if you guys just come out and say like, hey, we would love to share our use case, and that'll be fantastic.
Cool. And with that, unless there are more questions or feedback, I think we are a wrap.